It's time for us to do a demo, and what we're going to be doing is we're going to be setting up a scenario, a very simple scenario where we simulate a task that takes a long time, and then we're going to do it in both the ordinary fashion as well as the async fashion. So let me just imagine that there is some calculation which takes a long time. So I'm going to have public int calculate value, and let's suppose this thing takes 5 seconds. So I'll do a thread.sleep here for 5,000 milliseconds, and then I'll return some value. So this is, you can think of it as a long-running task, and we're going to see what happens when you actually perform this task inside a Windows Forms application. So here it is. I'm going to add a couple of controls here. I'm going to drop a button as well as a label, and we're going to see how we can get the button to actually perform the calculation and output the results into a label. So I'm going to call the label LBO result, and the button might be called BTN calculate. There we go. And I'll even give it some text. Okay, so you press the button, and then some event handler fires, hopefully. As I double click this, let's see. Yeah, here it is. So this is where we're going to perform the calculation. And first of all, let me show you what happens if you just calculate the value as is. So we say int n equals calculate value, and then we assign the value to some control. So we say LBO result dot text equals n.toString. Okay, so you can already guess what's going to happen here, but I want to show it to you anyway, just to illustrate the fact that we're going to be blocking the UI thread for a whole of 5 seconds. So here is the application. I press calculate, and notice as I cannot resize the window, I cannot even move the window anywhere because it's taking 5 seconds, and during those 5 seconds the UI thread is blocked, which is precisely what you want to avoid. You want to avoid blocking the current thread. So how can we fix this? Well, before we jump into the async and await approach, I want to show you how you would do this just using ordinary tasks, because that's possible. Okay, so let's get rid of this calculate value. We're going to do it differently. We're going to have a public task of int calculate value async. So that async word at the moment doesn't mean much because I'm not going to be using async and await. So let's suppose I have this method, and what it does is instead of returning the integer, the result of the calculation, it returns task.factory.startNew, and this does the same thing as before. So we have thread.sleep for 5 seconds, not sheep, sleep, and then return 123. So let's suppose we do something like this. Now what this means is that when you get here, you can launch the calculation on a separate thread, because that's what task.factory.startNew actually does. You can launch it on a separate thread, and then you can do a continuation. So you'll do something like the following. You'd say var calculation equals calculate value async. So you're firing up the calculation, and then at some point you want the result. So you say calculation dot continue with, and you're saying here is the task, and when you actually get the task, can you please set the result? So LBO result.text is equal to t.result.toString, and can you please make sure that this all gets called on the UI thread? And for this we need to do task scheduler from current synchronization context. So if we do this, we're going to get the perfect result, because we're spawning off a calculation on a separate thread, and then we have a continuation on it. So let me show you how this works. So I press the button calculate, but notice I can now resize the window, I can move the window, I can do whatever I want because we haven't blocked the thread, and at some point I get the final value, 123. So that is what we are trying to achieve, but we're trying to achieve it using the syntax sugar provided to us by C#. So instead of doing it like this, we're going to change calculate value async once again. We're going to do slightly different things because we want to get rid of all of these trappings of using task. We just want to basically avoid all of this. So how is this done? Well, first of all, if we want to do thread.sleep, we now need to do something different. Instead of performing an ordinary thread.sleep in the context of the async and await paradigm, we're going to call task.delay for, once again, 5,000 seconds. So as you can see, what happens with task.delay is it creates a task. So it basically takes a thread on the thread pool and runs a task which simply waits for 5 seconds. Now what we're going to do is we're going to actually await this task. So essentially we're going to wait for this task to complete, and then the continuation of that task will be to return the value 123. Now, as you can see, you cannot use the await keyword unless you have a method which is marked as async. So let's add that. And now everything is valid. Now, even though you're returning an integer, having a task of integer in the signature is absolutely fine. Okay. So now we can get rid of all of this because things are getting a lot simpler in actual fact. Because now what you can say is you can say int value equals await calculate value async, like so. And then once you have the value, you can say lbo result.text equals value.toString. Okay. So what's going on here? Well, as you can see, once again, since you're using await, the method has to be marked as async. Now, as I mentioned already, the only reason why we have async in the first place, it's kind of like an indicator that we are allowing the use of the await keyword. So that's that. Essentially, you fire up calculate value async on a separate thread. What this does internally is it launches a task which waits for 5 seconds and then continues by returning the value 123. And then this part of code continues by taking that value, which is here. It's sort of being unwrapped from the task, as you can see automatically, and getting that value into the label, which of course happens on the UI thread. So this line I've highlighted happens on the UI thread, which is why everything is okay, because if we didn't, if we did this on the thread where this thing was executed in this task, then we would have a problem. We would have a cross-thread kind of issue. So let's once again try this out and see how it works. Okay, so same idea, we press the calculate button, and as you can see, I can still manipulate the window in all sorts of ways, and sooner or later, after 5 seconds, we get our final value. So this is the gist of async and await. Now, you can also have more than one await, obviously, because you can have a continuation of a continuation of a continuation all the way to infinity, however many you want. In actual fact, what happens behind the scenes is C# makes a kind of state machine for you to go through. So it's easy for us on this end because we're continuing to work with the ordinary programming model. So let's suppose that I want to wait for 5 seconds after this result has been updated. Once again, since I'm in an async method, I can await task.delay for further 5 seconds. And then what I can do is I can use one of the many APIs inside the .NET framework which actually support this async await paradigm. So for example, if you're downloading a web page as a string and you want to download an entire page and analyze it, for example, you also now have the APIs to do that. So let's use a web client. So using var wc equals new web client. So web client is precisely the thing that you want to use to actually download something. And if I now say string data equals await, let's go to the new line, wc dot. So as we look at the APIs, there is download, and you can see that lots of these end with the word async. So when you see something ending with the word async, you know that it's going to return one of three things. So if it's a void method, if there is no return type, it's going to continue being a void. But it can also return a task or a task of T, where T is the return type. So in our case, we're interested in download string task async. So essentially this returns a task, and that task is parameterized on a string. So it's task of string. That means we're going to get a string as the end result. So download string async, and this is where you can specify the address. So here I can say, for example, google.com/robots.txt if I want to analyze their robots file. And once I have this, what I can do is I can have a continuation where I actually use this data. So lbo result.text, and I can take the data, I can split it, let's say on a line break, take the first value, which is going to be user agent */*, something like that. I can trim it and assign it to the actual label. So just to recap what's happening here. So we're, first of all, as soon as this await happens, we're releasing this entire UI thread. So all of the things you see here selected, they're not happening on the UI thread. Only the continuations happen on preserving the context. So we await calculate value async. So calculate value async actually happens on the TPL thread, and then on the UI thread we assign the result. then we await task.delay. So we wait for 5 seconds, and then we get the web client. We wait for it to download the contents of the Google robots.txt. And once again, on the UI thread, we can update that and put it into the label. So let's actually run this, and let's see. This is kind of the final culminating demo of this lecture. So I'm going to press calculate. 5 seconds are meant to pass, and then we're going to see the value 123. Hopefully, here it is. And then furthermore, 5 seconds pass. And after the 5 seconds, we go off and we download the Google robots.txt, and we get the first line, which is user agent : star. So this has been a small demo of the async and await functionality. The takeaway from this is that ultimately, what happens is you're spawning threads, or you're using threads from the TPL thread pool without having to rewrite your code in terms of tasks. So you'll notice that we're avoiding task in most of these locations. Certainly the static factory for task.delay is something that we're using, but we're not making tasks explicitly. We're not using task.factory anywhere. So this is a very useful and very convenient kind of approach to actually working with a